This is our presentation on the Samsung Galaxy Note 7 failure. So we'll be going over the stakeholder analysis, as well as the requirement analysis, the system and design development, the final system design, the verification and validation process, and the reasons and causes behind the system's failure and the lessons that we learned. So on August 19th, 2016, Samsung released their newest phone, which was the Galaxy Note 7. After 2 months, it became the highest selling item, selling around 1.9 million phones. Samsung actually had to recall 2.5 million of those globally after 96 incidents were reported of the phone overheating and in some cases even catching on fire. So we'll be going over the internal and external stakeholder analysis. So for the internal stakeholders, we have the Samsung leadership team who needed the accurate reports from the quality assurance team and expected an on-time product launch as well as successful sales. The marketing team that needed confidence in their product as well as information about the product and expected for the product to match their expected sales. The quality assurance team that needed the ability to test the product under the given conditions and ensure safety, and expected for leadership to listen to their concerns and for standards to be met, as well as the battery division that needed requirements, budgets, and tolerances, and expected for the battery to integrate seamlessly within the product. Moving on to the external stakeholders, we have the customers who needed a reliable smartphone and expected a functional and reliable device, the retailers who needed the product to supply to the customers and expected good sales and refund support when it was necessary, the investors that needed transparency as well as positive finances and expected Samsung to repair their company image and rebuild public trust, and the competitors who needed competition in the market and expected consumers to flock to them and avoid Samsung's products.
The requirements. What do we want to prove is what Samsung was asking themselves. Features to improve on, or the goals, is how to get a slimmer phone, how to make the phone thinner without sacrificing too much. Processing speed. What CPU and chipset would be best used that be budget friendly. Longer battery life. What type of battery will we use that will give better performance and longevity that can fit in the case? And how do we make a lighter phone without sacrificing the screen size? So they had a baseline from the Samsung Galaxy Note 5, such as thickness, weight, chipset, CPU, and battery endurance, and they knew that this is the baseline of what the customers had, and they had to exceed that. So as we can see with the Samsung Galaxy Note 7, the thickness is a little thicker, but it did weigh less. The screen size and screen resolution was the same compared to the Samsung Galaxy Note 5, and the chipset and CPU that was used were better on processing speed and performance, and the battery endurance was up to 90 hours. So did they meet the requirements? Slimmer phone? No, the phone ended up being a little thicker than the old one. Longer battery life? Yes, the battery lasted an average 5 hours longer than the old design. Was it faster? Yes. The CPU and chipset that was used did have better performance. Did it weigh less? Yes, the phone did weigh 2 grams less than the old one. But the question is, were these hard requirements worth from what you just heard? A side-by-side comparison of the Note 5 and Note 7, as we can see, they are almost identical. Other than that, the Samsung Note 7 did perform faster and it was lighter.
System and design development. This diagram represents the functional architecture of the Samsung Galaxy Note 7. In systems engineering, we break down a complex product into what functions it must perform before we worry about the actual parts. At the top, we have the Note 7 as the overall system. It branches into 5 major functional subsystems. We have power management, processing, user interface, communications, and the enclosure. The lower level shows key sub-functions within those subsystems. In red, I've highlighted the energy storage module and enclosure interface. These are where the Note 7's functional breakdown occurred. The energy storage module's function was to store and deliver electrical energy safely. The enclosure's function was to protect components. By separating what the system does from how it is built, engineers can trace every requirement, ensuring coverage of all critical functions and design with purpose. It demonstrates how functional architecture provides a foundation for safe, reliable, and efficient system design.
So now let's take a look at the physical architecture, in which we take the physical product and break it down to subsystems until we get down to basic parts. And we can also use this architecture to trace a problem. Physical architecture diagram focuses primarily on tracing that problem, like we had said. And so we start with the phone itself, and we go down to the internal hardware, and we break that down to the lithium-ion battery. And then our problem was in the jelly roll structure, which is basically a cathode and anode, insulation tape, and separators. rolled up into the battery pouch. And specifically, the problem was and the first run was with the anode or the negative electrode. They extended too far into the roll, and in addition to that, they also had a dent which caused the anodes to push into the cathodes, create a short circuit, and that led to runaway heat generation. And after this problem came to light, Samsung did a recall and then also made a second run of it with a different battery, which ran into similar issues. And so in the second battery, the issue was still within the jelly roll, but the problem was with the cathode this time, the positive electrode, and the insulation tape. The soldering, there was too much heat in the soldering process, and that resulted in a dent that pushed the cathode into the anode. And in addition, there was insufficient insulation tape. And so we ended up with the same result despite the attempts to fix the original problem.
The final design for the Galaxy Note 7. The final system design at release had a 3,500 milliamp hour battery capacity, a 2.3 gigahertz CPU performance, a device weight of 169 grams, and a 90-hour battery endurance. Within the processing subsystem, they put in the advanced Exynos 8890 Octa chipset with improved performance and a power for enhanced user experience. In the energy storage module, high-capacity LiPo battery with fast charging capabilities and improved energy density for extended usage. In the physical architecture, they achieved a premium build quality with advanced materials and refined design aesthetics while maintaining device durability.
Moving on to reasons and causes. Why did it fail? What did we learn? First, let's take notes on the difference between the old and new designs. Galaxy Note 5 battery compartment that has a visible amount of space compared to the Galaxy Note 7, which is more compact. Let's question this. Why is this battery so tightly fitted compared to the Samsung Galaxy Note 5 battery design? Is this something that should be brought up? Lessons we learned from this, and what can we do to prevent failures in the future? I think we're asking the right questions. As engineers, we should constantly asking ourselves questions when designing. Since Samsung has such a great success with Samsung Galaxy Note 5, there should be a dedicated team to the two hardware designs, and if a new design would have compromised important assets. Quoting Avery Greengart, I truly think that it's in Samsung's best interest at this point to have a radical transparency, because this isn't a product problem as much as it is a brand problem. If you don't trust Samsung, you aren't going to buy their products, and that spreads far beyond the Note. Leading to what lessons did Samsung learn? What ultimately saved Samsung was them being transparent with the public about the causes Samsung Galaxy Note 7 incident. After explaining to the public of what caused the phones to explode, to regain public trust, they informed everyone of their new policies, such as implementing a new battery testing protocol to make sure the phones are safer, hiring more staff to comply with new standards, and give more space to battery compartment to compensate for battery expansion. An actual fun fact, Samsung managed to recall 96% of its phones globally because of the easy return and refund policy across stores. These are our references. Thank you, guys.